will introduce myself first. I'm KY. KY Lin, you can call me KY. Okay. So I need you all to introduce yourself because in the class I need to know your name.
Right.
Okay. So start from you first.
Okay. This community may have one restaurant.
All right.
So possibility for security. Then
How long you been there?
4 years.
Alright. Okay. 4 years. Okay. So working 4 years for process engineer. Okay.
My name is Muhammad Aziz.
Aziz.
You can call me Aziz. And as process
Engineer. So you both are colleagues. Same team. Okay.
I'm GH, so basically I'm a process lead. So I'm here to back up and for this process.
Okay. So before that, you all anyone have the printer process background?
Yeah, we are considered as model user.
Model user. Okay. So this class is for the process. The printer printing process is not for the printer because for the printer you need to hands-on have to on-site with the machine. Otherwise here I talk, you don't idea what I'm talking. Okay. So introduce yourself.
Hi, my name is Shayufo. You can call me Kenny, but I'm newbie from SIP.
Also you are from SID.
Today is the first day.
Okay.
So don't bully. Okay. So I will talk about the process foundation. Okay. So this is the session plan for the today, 4 hours. So I will talk about the process foundation. Then I will, in the end of the session, you'll be understanding the right way of the solder printer work. Basically, how the printer work. It's not like our printer machine, the printer for the paper. This is the solder base. Okay. Then understanding the solder printer hardware work, and then recognize type of the sensor and the production. Sensor, you all know, right? Sensor, right? Okay. Okay. Then understanding the effect of sensor aperture vs the solder paste type. Anyone know about aperture? Yeah. We call aperture, but some people it's called opening because it's a hole right on the sensor. So it's the same meaning. Understand? Okay, never mind. Later we will go through. Okay. So understanding the use of support tools in solder printer tooling. Okay. Understanding the clean cycle of the solder printer. Recognize the solder printer defect, and then manage the solder printer defect from the SPI result. So you all know the SPI, okay, inspection machine. So okay, so the learning will be introduction 10 minutes. I will introduce, okay, and then the solder printer works is around 1 hour, and then we get 5-minute break. Okay. If in the middle session you all need to go to the toilet, just raise the hand, okay? Then the key of printing medium, explanation of the defect, and the conclusion. Okay, and then after that we have a Q&A. Okay. Okay, cause of aim, why we need to understand the printer, because we need to provide the skill necessary to design and optimize a new product to maintain the quality of print throughout production, thus maximize the throughput and yield. So we also don't want to produce any scrap for the production. Okay. So the cost of progress in unit from the basic theory right through the process optimization, it also provides the opportunity to review a process and identify area of improvement. Okay. So the key of parameter of an effective solder paste printing process as follows. So as a process, we need to understand the squeegee speed. It means that the printing speed. Okay. Then the print pressure, the force you apply on the sensor. Okay. The squeegee angle, the squeegee length, the paste reflector. Then sensor separation speed, sensor separation distance, then sensor cleaning, sensor and squeegee condition, PCB support, print stroke, print defect, type, storage and handling, and wiper, and stencil design. So far, you all understand about this one, right?
Print stroke.
Print stroke. Print stroke means that how far we go, how many times we print.
Oh,
Okay, this is we call print stroke.
Speeding or the stencil angle?
squeezy angle.
Squeezing angle.
Itu 45 degree dan
You have
Oh,
two types of,
angle.
yeah, okay,
Okay,
okay.
okay.
Okay, you have two types, one is 60 and one is 45. Okay, so print stroke, some machine they are mentioning print distance. They are according to the
Means speedy distance or?
print distance means that the aperture, how far the opening the aperture is, then they will go through. So we call it print stroke. Okay. Anything you all don't understand about this one? You can raise your hand.
For
We
sure.
are close the door already, so you can ask any question. Don't worry.
For sure he got a lot of problem because first day of
First day, oh my
first
God.
day to not first day to Inari but first day to this place.
Okay, it's okay. No problem. After this one, you become expert already. Expert than me. Okay. Okay. So far, any words you all don't understand? Wiper. It's not your car wiper. It's the cleaning unit to wiper.
Oh,
Cleaning unit we call wiper.
the what it, I mean the
Yep. It's not the wiper you wipe your car. Okay.
But what is the wiper dia on bottom dia on top kan?
No, there bottom only. Don't have
Bottom
top.
only.
Because top is your solder based on the sensor already. Okay. So I will introduce to the stencil printing. Okay. What is the objective of the SMT or surface mount assembly process? To provide a conducting path between the board or substrate. Substrate, anyone know? No. Okay. So to provide a conducting path between the board or substrate and component throughout the design life of the product. Substrate is something like the pack circuit. Some circuit they are I can demo because
Oh, so that one called substrate.
Substrate, yeah, it's a piece of copper layer. Substrate. PCB is the green color board. Okay, printed circuit board. Okay.
We jump for all the girls.
It's okay. As long as we know each other what we are talking about, then it's okay already, right? Then what is the objective of the stencil print process? Accurately deposit the correct volume of material onto each of the pad to be soldered. If not control the volume correctly, account for the majority of assembly defect. What we don't want to be is we don't want to create defect. So we try to optimize the printer process. Okay. So stencil. So this is called aperture. Aperture is the center of the hole, which is called opening. Okay, so this is the aperture. So inside the aperture, we will see the aperture width, aperture length, and the stencil thickness. Okay. Understood? So far, no problem. Okay. So I will roughly go through the printer process, how the printer works. Okay, it's not black magic. It's something mechanical. Okay. So the stencil print theory. So at first, squeegee process. You have to have squeegee angle, print speed, print pressure, the paste behavior, and the paste roll volume. What is the paste behavior? What kind of paste you are using? Okay. Paste roll volume. This is very important also. Some of the machine they already the paste roll volume means that during you printing, right, the paste will roll on the squeegee. So when they less to certain volume, your printing will have a lot of defect. Okay, it's not like you simply pour a lot or a little, then you will have a defect. Yeah, because you all are the process. Usually you all won't standing in front of the machine, right? But sometimes you will.
No, we are sending
Yes,
from
we are
but you are not the one who running the.
Yeah, it's a bit different because we are R&D team, so usually we will is the one that runs the.
Yeah. But this one is just some basic knowledge. No, it's some extra knowledge for you. When you go through the line, you saw the printer, you saw the pace reducing on the squeegee, and then the operator say, "Abang, cukup lagi." And then you will see some defect happen behind it. So later I will explain about how it works. Okay. So the sensor printing process, we need to have a zero gap. Zero print gap means that your sensor and your PCB must be zero gap. This is the sensor, this is the PCB. You cannot have any gap over here unless the sensor is broken.
Okay. We purposely create gap.
Unless you are printing for the laptop, they have some process regarding some printing process can require the print gap. But for the USB, currently we are running one, cannot have. Unless your tooling has some problem. Okay.
So this is standard process.
Standard, yes, standard. Okay. So we have to control the print speed, even the squeegee pressure. They are both girlfriend and boyfriend. Their relationship are very close. Okay. So the board is lower under controller separation speed. Okay. So what we need and what we want for the printer outcome is for the SPM machine we have to print like this. There is leading edge flat on top, height equal to sensor thickness and good alignment and no smearing. So this is the purple pad. This is your solder paste. Must be very accurate and very nice and perfect. Okay. So this is how the printer works. For the new guy, you have to understand. I have to see here how the printer is running. Okay. At first, we have a sensor frame to unload our sensor. So this is our sensor, the pink color. Then this is our substrate of PCB. Okay. Then this is our tooling and table. Okay. This photo, anyone understand?
Table is the design machine, right?
Yeah. Okay. So good. Okay. Did you have a question, you know? Okay. So at first, this is the basic one. Then at first, when the board is reached the center of the machine, then the camera will capture the visual of the board and the sensor. So they will capture the visual for aligning the sensor and the PCB for printing. This is very basic process. Okay. Then after that, the table will push the tooling and the reel together after the inspection. Okay. At this point, what kind of thing you need to check from your naked eye? A very basic one. You just see from where they reach the print height.
So actually you can see the gap on the opening.
Yes. You want to see the gold color, the purple pad on the aperture, right? You don't want to see any green color, right?
That means the alignment going up, no? Kita
can. Because if you are running the PCB, if the alignment is not good enough, you will see that green color is on the aperture or the white color. Okay? Okay. So the front squeegee will start lower down to press the solder, and then it will start to roll. It will start to roll means that all the print material will fall onto the aperture. Okay. Then after that, the table will lower down. Okay. then the tooling will go down, and then your substrate can be moved up. Any question? Any question? I believe you two are quite expert for this one. Some basic, then you can. Understand?
Yeah.
I'm not sure you all understand. Otherwise, my effort is gone. Yeah, that's us. We are close the door. Don't worry. Okay. So far, understand? Okay. You okay? No problem. Okay, so this is a key of printing. Actually, this is the fishbone chart. This fishbone chart is already mentioning everything, explaining everything. But this is for who are expert already. But for us, we are new guy. We see on the chart, we can maybe understand for 10% only. Okay. Okay. So the key of printing we have through the cleaning process, the solder paste, printer setup and sensor. This is what we are considering. Okay. Okay. So for every machine printing machine, sorry, you all need to have a subject or what? No need. So I can proceed now. Okay. So for the squeegee speed, what is the squeegee speed? Okay, so the squeegee speed is means the printing speed, how fast you go. Okay, for printing speed, the speed range is from 25 mm per second to 200 mm per second. Maybe some machine maybe can go to 300 very fast. I don't know. Okay, so the possible printing speed is determined by the solder paste behavior. What kind of flux you are using for the solder paste. Okay. The speed can be increased until the solder paste rolls perfectly on top of the sensor. Okay. If the speed is set too high, the solder paste will slide on the sensor, will not feel the temperature. What does this mean? No?
Stick on the squeegee.
Yep.
It's not fall into the hole.
Yep. Because the sensor is the shining finishing. So if you too fast, the solder is not even stick on the sensor. It's like go through. Okay. So there is often no benefit in running the printer at high speed if the board are to wait on the conveyor for a long time. If the cycle time is not critical, then generally the lowest print speed is selected as this normal create this problem. Understand?
So what you mean wait on the conveyor means that the backend process is slower than your printer.
Yep. Okay, so for SFP line, we have a printer, we have a conveyor, we have a loader, we have a conveyor, either one, and then printer. Then after that we will have a conveyor, have a SPM machine. Okay, then after that we will conveyor again. Then we have a motor, right? So mean that you have to see which board, the board is stopping at which location. If it's stopping in front of our printer, means our problem. Printer have slow. If the board is waiting, is stop after printer, means that maybe it's SPI. This is how we see the cycle time. Not cycle time. The bottleneck. Yeah. Sorry. Okay. It's not because of you want crazy output, gila output, gila output, and then you bring fast, and then you will see a lot of problem. Okay. So okay. Okay. This is very important for process. So ideally pressure is kg is equal to the squeegee blade divided by 50. So you have a squeegee blade for 300 mm. So ideally is around 6 kilo, but sometimes we will plus minus 4 to 5 kg. This depends on your solder paste. So this one is a guideline for you all. Okay, the larger the squeegee, the larger the force you need. put some knowledge in your pocket already. Okay. So basically for process, for my own use, basically I will see the species, and then I will plus minus around 3 to 5 kg. Because you cannot too strong. If your board is very thin, okay. During the pin cycle, it's important to apply sufficient pressure across the entire length of the squeegee blade to ensure a clean wipe of the sensor. Okay. If the pin speed goes up, the pressure must go up to ensure a clean sensor. Okay. If the board to be printed suffer from warp, the pressure may need to be increased to ensure a flat surface and good gasket. Choosing stiffer squeegee blade can also help this. Okay, maybe you all don't understand what is the good gasket. Good gasket is mean that zero gap. Good gasket, we don't want to have any gap. Then normally printer will have facing the warpage issue for the second process of the PCB. The first PCB, the fresh PCB come in is very flat. Okay, after you go through reflow oven, it will shrink, it will warp. It will either warp outward or downward. Okay, either way. So we have to apply more pressure. Okay. Then from the second sentence, to ensure a clean wipe of sensor. This one. We also see for our naked eye. If you go through the machine, you have to see the you see the NPM. NPM is the machine is flat, right? Then the back one is curved, right? You can open the light. You can open the light from the in the printer, right? Okay, so it's okay. This one is not correct. Don't do it in front of safety. Okay.
Our machine is way too manual, so we have to do this.
Okay. So from the basic one, to ensure a clean wipe of the sensor means that after you bring the surface of the sensor, surface of top and top bottom has to be clean. It's not, you cannot have any residues of the sensor, of the solder. Okay, so this one is very important. You can capture photo also for your process. So the squeegee print pressure too low, excessive print height, incomplete sufficient solder, too high, you will causing scooping and bridging. So when your pressure is go up, your speed has to be go up. So the print speed and pressure are directly related. Increase the speed require a corresponding increase the pressure in order to maintain the same print result.
Scoping is what?
Don't know. Scooping, don't know. Okay. Scooping is if your pressure is too high, because sensor is maybe 4 to 5 mil, and then your squeegee when pressed too hard, the paste supposed to be at 4 mil, but maybe it's scoop. It will scoop a bit.
Also the volume too high.
Yeah. So from the SPI we call is insufficient, but the scooping is like you scoop the ice cream, it will become like this.
Is it like stick to one side only?
Yep. Depend on which stroke you are looking at, front stroke or reverse stroke. Okay.
Not.
Yes.
Yeah.
Okay. No question. A lot of people will confuse about when the printing speed is increased, the pressure will reduce. It will go other way. Your printing speed increase, your pressure must be increased. But some people will, most of people they will.
You mean adjust accordingly lah.
Okay. Okay.
Biasa kita buat balik ya.
Yes. Not only you, everyone. Sometimes me also will do like this. Confused already, right?
Everyone a very quick punya apa? Respond after.
Yeah. You see,
So the correct way is to maintain the correct blade, the force per the for the size, for the length is it?
Yeah.
And then faster, then you need to increase more pressure to,
Yeah.
to make it.
Yeah, but actually when you doing troubleshooting for the process, you don't one time you troubleshoot all the things. You one by one. You speed first, and then you reduce speed, and then only go to the pressure. You don't pressure. You don't suddenly you hunt down all, and then you don't know what is happening. Right? But this one almost happened at everywhere. It's Scully you do everything because my manager is asking me, why no output? I need output. Faster. So everything will go was okay. So the squeegee, the angle of the squeegee is typically set at 60. By the holder they are fixed to. If the angle is increased, it can cause the scooping. Then of the solder paste from the sensor aperture, and so less solder to be deposited. If the angle is reduced, it can be cause residue of the solder paste to be left on the stencil after the squeegee have a complete print. So from the photo we can see that this is the scooping. Okay. And then this one is leftover. Huh? Depends. What squeegee you using?
The angle.
Not really paying attention.
Okay, it's okay.
We take whatever we get. Then see the result. Okay. And then adjust again.
But normally the squeegee angle tu because pressure juga.
So this is the squeegee angle. Okay. So 45 degree, we have two tabs. Okay, 45 and 60 degree. So the 45 is increase the force, high speed printing, printing stencil, printing glue, printing mesh screen, and for the 60 degree, for the standard SMT printing. You all know about mesh?
Right?
Mesh stencil?
Match.
Mesh stencil? No. Later I will show you. So the photo here is the squeegee holder. So this is the squeegee blade. Anyway. Take photo already? I don't know. I have to touch video. Okay. Okay, so squeegee length. So the correct squeegee length. You choose the correct squeegee length and choose the closest length to the board size. So you will have a plain stencil surface. How you all choose the squeegee?
We take whatever we get.
Okay, you have to identify your board size, your board length. If your board length is around 220, your squeegee have to be 300.
Yeah. I mean, actually longer than.
Yes, it must be longer than, but it's not too long. You cannot too old your length, and then you get 400 because you say that you get whatever you use, right? You use whatever you get, so you cannot take too long. It will cause another problem. Okay? Because the longer the squeegee, you have to apply more force.
Tune more force, right? So is it saying that I can use any of the squeegee as long as I fine tune my recipe?
No,
Not really.
not really. If too long, it will when you press your stencil will become warm. Because the center of the stencil have the board and some support, but the side there you don't have any support. Okay. And then you have to consider one more thing is because your squeegee has a deflector, paste deflector. Later I will show you. So this is a very ideal printing. Then this one is not very ideal. Means that you can solve a lot of residue. here and then inside here. Okay. So incorrect squeegee leg, overlap squeegee use, left over a lot of dry paste at the both sides of the stencil, lead to undesired result and defect. Because you're running the printer for some time, then the paste is remain at the side. If you can't start to dry, when it dry, and then you running, and then the paste might go into the aperture and may cause clogging.
Any formula saying that the length versus that length is need to have 1 point something?
No, just because our squeegee length is 200, 250, 300, 350, 400, 450. So just find the suitable for the both sides.
Slightly larger.
Slightly, yeah. Okay, so what is called paste deflector?
Oh, the one there.
You scoop away, you scoop your solder inside. Paste deflector. Okay. These are highly recommended when printing solder paste. They are ensure that the paste is contained within the squeegee length, thus eliminating the trend and ensure an even paste roll diameter. Okay. Without the paste deflector, paste tend to escape from the edge of the blade and the paste can dry at the side of the stencil. Okay. It will cause a lot of waste on the stencil. If you don't have the paste deflector, your paste will intend to escape from the center and go to the side. Okay?
That is just a feature of what?
No, every squeegee has a deflector.
You remember that? Yes, new squeegee, that old squeegee one, they have exactly like what color beside.
You have a white color, you have metal, you have the rubber one.
The one is like plastic material, the side.
Yep.
The new deck one all have this.
You didn't notice about it, right? This one is very important, otherwise your paste will intend to go inside. Okay. So paste deflector. Paste deflector must be fit low enough to minimize the trend line, but too low could result in serious stencil damage. Okay. Paste deflector use a clean stencil and even pressure across full squeegee length. And the paste fill and uneven pressure across the squeegee length without the paste deflector. So from the first sentence, this means that you must have a paste deflector, and then the paste deflector is a flexible mechanical. So when you apply the force on the stencil, the squeegee is go down, but your paste deflector will stop on the side, on the top of the stencil. It won't go down together, otherwise the stencil will be broken. So the paste deflector is to let the paste to go to the center again. Okay. Squeegee blade. There are two types of squeegee blade type: metal squeegee, step down metal squeegee, and stepped metal squeegee. There are three things different, totally different things. But the second and third one seem like the same. So metal squeegee blades are most commonly used due to material rigidity and able to operate at low pressure. Okay, later I will show you how it works and why we use that. So less cooling effect from the aperture and do not wear easily. Okay, so from the photo, the first photo, this one is the normal squeegee blade, okay? So step down squeegee blade, you will notice that here in the front there, we have a step down already. Means that become more inner. Yeah, this is some process they require this kind of process.
Like knife,
Basically squeegee blade is already like knife.
So you mean that
You will step down again. step down become more thinner. Yeah, thinner.
Oh, it's just
Thinner only.
slightly same angle lah, the down. Not the one side.
No. Okay, so for the step metal squeegee plate, okay, here we will open a hole. This one is for some process. Later I will show you. Don't worry about that. Okay, so this is a very normal squeegee blade. Squeegee blade are laser cut from a specially selected 0.3 mm, 0.2 mm and 0.15 mm. A new stainless steel are ideal for application that contain a mix of components. Okay, they offer a wide pressure window, excellent consistency and minimal wear. Okay. So step down squeegee. Step down metal squeegee. Step down metal squeegee are made at edge from 0.3 stainless steel with the edge feeder down to 0.15 thickness. Okay, it able adapt better than normal metal squeegee blade. Okay. Is instance where a rise of PCB feature is adjacent to fine pitch aperture, it can create interruption to the tensile flatness that cause the squeegee blade to jump or skip over an aperture, leading to either retention of paste in the aperture, also leading to an insufficient or possible smearing and bridging.
Means that it purposely make the blade more thinner so that it can flexible.
Yep. Okay, because some of the PCB you have some step up on the PCB, have some marking or the barcode. Maybe if you because the barcode is too big, and then when you skip, you will like jump. Okay.
So with the step down, it will help to like more flexible.
Yep. Standard blade was extra facility at the interface with the sensor surface and can adjust their profile without sacrificing the print quality to achieve cleaner, more consistent print deposit. On the photo that you can see, there was something here. So if your squeegee blade is the normal one, it will skip. The skip means that like jump. Okay. Because the other squeegee, the squeegee at other places already move, and then the side it become force friction, and then it will skip. Okay. So, step metal squeegee. Okay, what is a step metal squeegee? Step metal squeegee blades are used for step stencil that have a large step up. Okay, the slit is custom designed to match where the step up is on the stencil. Normally, the slits are placed close to the side of the step up, allowing a portion of the blade to rise up on the step, while the remainder of the blade stay in contact with the lower section of the stencil. Never see of this way. How about step up stencil?
Yeah. So it's the same concept where we can create different height so that we can.
But this one is for only for that particular part you are focusing.
First is to make the volume slightly different.
Because your stencil is bigger. So if you use the normal squeegee, it will skip also. But this one, it maybe is used for the BGA. So far, you all seen any step up stencil?
We use the stencil
On the top or on the bottom?
Bottom. Because we have some something like pre-deposit, so the base.
Okay.
So carry up, just not to print that area.
Okay.
But overall, it's still flat.
Flat on the top.
But
on the bottom is already step up.
Yeah.
Okay. Okay. what is the separation speed? Okay, so a separation speed of up to 3 mm per second should be used in governor and sorry, a speed setting up for of up to 3 mm per second should be used and is governed by the size of aperture within the sensor. If this is too fast, it will cause the solder paste not fully released from the aperture, and the formation of high edge around deposit is also known as dot here. If your separation speed is too fast, your paste is not sitting on the PCB or on the control pad, and then you already release. Okay? You understand about dot here? The dot here.
First time
First time dot here or in cost bearing. In cost bearing. Yeah, it's something that's very like top. It's on top.
So it's too fast when you have this.
Depend on your flux also. Paste. Okay. Sensor saturation speed, the paste viscosity, aperture size, temperature, humidity, and sensor manufacturing method are all factors that may determine the best saturation speed. Okay? If difficult to predict what effect changing the saturation speed will have on the print, so experimental is vital. So you have to test. You cannot, I give you this paste, you run for me. You have to test first, okay? It should be noted that the saturation speed could have a large effect on the print cycle time. The slower the cycle time will be longer. So far, any question? Any? Yeah, that ask question. Sensor separation distance. So every machine you have a separation speed and separation distance. How fast you go? Okay. This should be minimum required to allow the paste to clear the sensor at programmable separation speed. If the separation speed is set to maximum, the distance doesn't really matter, so should be set to its lower value. If the separation speed is slow, then the separation distance should be equal to the sensor signal plus a little extra to account for any sensor stretch. This separation speed and separation distance, they are both relationship are directly linked. Okay. So if you use the slower, your cycle time will be longer. Okay. So one of the sensor, anyone know sensor, right? Okay. One of the important part of the surface mount assembly process is application of a solder paste to print circuit board. PCB. No PCB. The green color PCB. Okay. This is generally achieved by the use of the sensor. A sensor is a thin sheet of material, typically stainless steel, with a series of aperture we call hole cut into it, which the PCB to be printed. The function of the solder paste sensor is to accurately deposit the correct amount of solder paste onto the surface mount pad so that the solder joint between the PCB pad and the component terminal are flexible regarding the electrical connection and mechanical structure. So sensor is is a piece of stainless steel with a opening. Okay. For the mesh, what is mesh? The stencil, we have a stencil. You saw the white color one? You saw the side, that's the mesh. Some of the process like SMT, Semicon, they are printing for the epoxy, the glue, they are using mesh. Mesh is something like you printing your t-shirt. You will print like this one. Okay. The one can broken up. structural college. This one is another process. Mesh is something like because you are using solder paste. Solder paste, the ball it cannot go through the mesh. It's a totally different process.
Also depending on the material that you want to create inside the what material.
Because you solder paste have a ball, but the mesh you don't have. You painting material like the flask, the glue, all is liquid. You don't have any solder the solder ball inside. Okay.
So but for our stencil, the mesh is just to hold the stencil.
They have some few grade of the stencil. Depend on what kind of requirement you need.
Malaysia dulu dia ada effect.
Yeah. What's the effect? What is the important for the effect? Cost for the stencil. The better grade of the stencil means the higher the cost. Right? Alright. You better car, you can run faster, right?
How to consider better grade of stencil?
Later I will show you. Okay. That one later. Too fast already. Okay. Our kawan might be confused later.
Kami nak cari kapan saja.
But not necessarily that the more you pay and then you get the better stencil and then you can run. You must understand what kind of stencil and why you are running with this and that. Okay. Okay. So I think we need to have a short break because after this you will have more the stencil thickness. How you check? I give you a stencil. How you going to know what is the stencil thickness?
Like that.
Other than that, very simple. Okay. You take out the stencil. Your stencil. Then bottom there have written that the stencil thickness 4 mil, 5 mil, 4.5 mil. Step down something like this one. Okay. For the aperture design, what is aperture? Aperture is opening. Stencil material, stencil mounting is the stencil frame. Okay. Okay, then the PCB design specification. Specified. A stencil alignment and then the PCB design specified. Okay, what is the stencil thickness? So the problem encountered when using a large stencil for both small and large component. Okay. From the photo you can see that we have two kind of stencil, two kind of opening. One is for the large component, one is for the small component. Okay, so the narrow one. Okay, the thicker stencil gives a sufficient space for forming acceptable solder fillet after refold. Okay, so it means that the stencil we are fully filled with the solder paste. Okay, from this photo you print with separation, means that the stencil and the board is separation. Then you can see that the paste is all fully done and then there was little. Then from here we can notice that this one is causing another issue, clogging. So the next board come in, you won't see anything. Okay. So poor paste release from the small component result in insufficient solder paste or dry solder joint. To join and nothing. Okay. So another is the stencil thickness. The problem encountered when using a thin stencil for both small and large component. Okay. There is a good paste transfer from the small component used. Small component resulting in good solder fillet. Okay. But for the large component, there is insufficient solder paste volume to form a good solder joint fillet. Okay. Okay, this is very important. Very important for you, for everyone. in the customer. Okay. Determine the requirement thickness of the sensor according to the information provided by the customer or the VGA on the PCB board or the minimum pitch of the minimum chip component of the IC. The ratio between the aperture width and sensor thickness should be not smaller than 1.5 for a good transfer, else resulting in clogging. Okay. A normal sensor aperture guideline is to keep the ratio more than 0.66. What is the aspect ratio and aspect area ratio? This is very important. For the aspect ratio 1.5, more than 1.5, the solar paste releasing good solar paste. Okay, and then the area ratio 0.66 aperture guideline. You know, you understand? Totally understand.
The ratio, area ratio.
Area ratio, look,
Area
understand?
ratio, aspect ratio.
Aspect ratio means that what kind of paste, the paste and the aperture, the type of paste means that at first we all understand the type of paste. No? The larger the number of type,
The larger the smaller the solar ball.
yes, this one. Okay, so means that the type is releasing related to the aspect ratio. If you use the larger type, means that the solar ball inside is very big. It will start clogging, so your aspect ratio will be very low. Okay.
Oh, I thought the one they calculate by let's say 5 ball.
5 ball.
The must keep 5 ball.
Okay. Yeah, it's correct. Correct. This is the correct thing you say. But the thing is, if today I'm using Tab 4, okay, but tomorrow the customer say I don't want, I cannot afford for Tab 4. I want to use the Tab 3. Then what will happen? You use the aspect ratio formula. You can see that the solar ball inside the aperture is already bigger than the width of the aperture if you start clogging. Okay, then your solar paste will have insufficient. Okay.
Usually kita kira ni itu sensor yang buat bagi yang kira bagi.
Yeah, this is the problem.
That's why I familiar with
That's why,
the area ratio. Tapi aspect ratio tak senang juga.
Aspect ratio, yeah. So the sensor thickness. So the aspect ratio is means that the width of the aperture and the over the sensor thickness. Okay, the area ratio. Okay, the area of the aperture and the area of the aperture wall. This formula.
So just now you mentioned about 5 solder ball, which so can the concept apply to all? Means that we take component in our aperture, we take the minimum width, I mean the minimum area.
The smallest aperture you in the smallest component.
Then divide by the 5 ball. I mean as long as you can fit 5 ball, then should be fine already, right?
This is a direct formula. You can calculate like this. But you have to understand that what type of surface you're using and what size of the solar ball inside.
Maybe I got to do. Maybe I just got the ball by the inside.
So this is a sensor thickness. This is a IPC standard. You can Google it. You can find it. Okay.
Oh, okay, this standard.
The standard.
Sensor punya.
So normally the sensor design is take from the turbo down.
Sorry, back to the previous one. This is the opening. How about if let's say the pad design is larger sometimes? We also need to play around with
Normally we will look at the smallest component.
this.
The smallest component for the aperture in the sensor.
Yeah, sometimes the designer, the PCB designer, they don't really design their pads based on the component size. They might
You mean
just
the
have
shape is it?
a,
You mean the
yeah, the
shape?
pad, for example, the components sit on the pad, right? So sometimes it is a ground pad, so they don't really care. So sometimes they they just make a larger cap for us, and then do we need to follow this, or we need to increase yeah, correct. You get me? Our component size maybe the pad is so big, then our size is here. So based on this, maybe it is a O201. So O201 by right, which I should only have this kind of volume. Because of the pad they design slightly larger, should I fit to have to fit that pad size, right, but not the component, right?
So much global punya size.
Has smaller.
Follow itu global ya.
Global
like size.
So to design the sensor, okay, at first you have to have the global file, and then you have to check the smallest and the biggest component size. You have to compare. Okay, then check the footprint thickness of the component of the data sheet. This is some example. I just roughly take IC unit. Okay, then you calculate the aspect ratio and the area ratio of the component, and then you design the sensor aperture. This is just a flow way, okay, for the aspect ratio and area ratio use. Okay. Anything make you bro?
What's the file?
Global file is
You want to design a PCB, right? The drawing.
They use a tool.
So basically it's a drawing to describe the.
it's something like we call grouping, because it's something global is something a grouping of the PCB 蓝图啊，蓝图的话就是你的 component 的位置或什么啊 ，OK。所以我们在这边是叫 global file。
它是一种format来的，就像 text file 啊 ，word file，虽然这个叫 global file，所以那个 global file 里面global file 里面就是他们在画那个 PCB 时候的那个 pattern，那个 genre，
something like that，我们在把这个 grouping 啊，对吧 ？OK。So the sensor aperture design is important to stop the solder defect from forming such a breaching or solder bit. If the area ratio is violated, the aperture is to be oversized. So try to avoid the making aperture 1.1 with the pad. Understand? 没有 break 下。
break 下。
因为看看他们前面那有 break 的时候，他们OK 了，照左线。他们想最后走的才到这个比较重要的时候，就他们break 1分钟。
哦，你自己安排的。
Okay, so during just now what you say, we design the sensor aperture, try to avoid 1.1. Exactly fit to the compact. Okay, the final spacing between the aperture should be more than the thickness. Okay.
This situation still need the 1x1 effect, right?
Sorry?
Still got the situation need 1x1 effect in the sensing and everything. Is it try to avoid making use 1x1? But still there's a condition still need 1x1 or less.
Some larger one maybe you can 1x1, but smaller one no.
Sometimes you more than that. Sometimes maybe more than that.
The pad is smaller but the opening will be bigger.
Because we have quite huge. Sometimes we our component size is larger, and then we have a minimum. Maybe 4105. So maybe 4105 that side because of the thickness, so we have to make the.
Yeah. This is depend on the condition also. Okay.
But like that you have a solder ball issue. If the solder is stick to the mask and unable to pull back after reflow, then it will create a solder ball there.
But if let's say we didn't do that, it will block inside the stencil.
So you have to use the correct ball size.
You have to use the better surface, better type of the surface. This
And boss tell us we cannot afford for license. We have to use like 4 to achieve that.
So this is I know what you all facing sometimes. Okay. So the design of the PCB pad also resulting of the solder joint. So the aperture design. Okay. Most aperture are designed to be slightly smaller than the pads. Okay. Typically 2 tau or 2 micrometer. Reduction all around or the printed at 10% reduce the pad to provide a good gasket sealing between stencil and PCB, but some aperture use special design to deposit less paste on the inner edge of the part to reduce the possibility of leaching. Solder ball forming. Okay. Below is an example possible solution known as complete aperture of the photo of mid-chip solder ball. Okay, you understand mid-chip? We call solder ball. Means that when during the paste and the you flow, the solder will melt and then it will start to form pushing from the center of the
So that's how mid-chip.
mid-chip. Means that the solder is too much on the overlap.
So we have to make
Smaller.
we have to make it smaller with the foam.
You can have a lot of kind of design of the pattern of the aperture design. Okay. For the new guy, when you looking at this one is not the solder randomly fly or randomly come out from another place. It's because of the solder when it's melt and then your component will press and then will squeeze out. Okay.
From more.
Huh?
From more.
You need to reduce. Okay. Okay, so rules of thumb. Keep a minimum 5 solder ball per aperture size, as what you understand just now you already mentioned. Okay, the smaller the particle size, the better print definition, but the paste will be more expensive and a greater chance of inflow problem. Okay, 5 balls. Not exactly need to be 5 balls, sometimes it has to be more, but 5 balls is a minimum requirement. Understand what it means that okay, this is our stencil, this is our aperture. Means that in the width of the stencil opening, we must have minimum 5 ball, 5 solder ball. So the case inside is a solder ball. Okay, so you see from the microscope, you can see ball is inside the aperture, the opening.
For the stencil opening, you can see this is the back design. So do we have to do the opening? Is it opening on this like this or you have open on the top and on the top? Do you understand?
Yeah,
So I think for our one, the back design.
You can either follow or you can ignore also can as long as the solder is sufficient and it's not creating any physical through here, then it
This is the purpose. This is the purpose.
that allow you to absorb. So we have to ignore the top metal lah. Just design the aperture really the bigger lah. Also depends on what is the thickness of the stencil you might need to use.
So, okay, material. So this is the aperture design. Okay, this is our aperture design. But this one is depend on people. Sometimes the name is different. Okay.
So got one component saddle.
You see this one you work.
We
You can come closer to the room. For you and you, I think you all don't answer yet. Where is the finisher of your stencil? Can you find for me? Yes. So normally they will have 3 or 4. Okay. So we are using 3, 2 or 3. It won't be 4. Okay. So the finisher here and here and here and here is up to you. Which one you prefer? Okay. So they will have a finisher over here and here. So when the camera goes to here, it will align and then it will go up. Okay. This is how it works. Okay. So this is the finisher. Okay. So this is typically the normal stencil how you look. This is the stencil. So this is the mesh model. Here is the mesh. It's supposedly to be the mesh. I don't know. Someone take it. Okay, so this is the mesh. Yeah. Front and back. Okay, so this is the center. This is the area we need to frame. Okay. Alright. So this is normally how the stencil works. And then this is the we are not going to use stencil anymore, but I can show you what the person will do. The operator will chit chat like this. When chit chat like this, will sit. Seriously, I saw before. So this is not going to happen if you all know. Okay, try to prevent it. So the hole inside here is the aperture. So you can see a lot of design. You can have a look. This is all the aperture. And then the design square, center, VGA. Okay. Okay. So we proceed the class. So everyone have a good lunch. Very good, very nice. So far so good. Okay. So I will talk about the block plan. What is block plan? Anyone know? Block plan means block plan? Okay. So clamping the PCB to the conveyor can be achieved mechanically using the H clamp, which are thin enough not to be implant squeegee travel, which are their corresponding short. Okay. What does this mean? It must be remembered that using clamp on PCB where the surface mount features are too close to the edge of the board can and thus leads to smearing, ridging, and or insufficient paste deposit. What does this mean? Okay, so for the first sentence means that this is our board clamp, this is your PCB. Yes. Okay, so this part has to be as thin as like a knife, very sharp. If too thick, when I travel, the stencil is the sensor is on top of here, right? On top of the board. If you're causing, here will be a gap. So it will be very sharp, very thin. Actually it's very thin and then it's a point, it become like knife. Okay? I guess back you can see a lot. The thin point at the bottom there. Doesn't pay attention. You will pay attention when you get caught. Everyone handling the drag will get cut because the point is very thin. But MPM you can choose. Okay? So this is very thin, and then normally if the ball clamp here, we have some component here will be very dangerous because it will causing smearing or insufficient. Because the squeegee when it move to there, the ball clamp is there already, it will squeaking. Okay, unless you are printing in the center of the PCB only. Okay, for this condition you can use. Okay. Alright. So, edge board clamping. What is edge board clamping? So, edge board clamping is edge board clamp. Yes. You also smart. Yeah. Okay. So edge board clamping for the here you can see this is a PCB, and then you don't have the board is the board clamp is not here. It's clamp already. So edge board clamp with alpha thin foil is the standard method most common for keeping the circuit board in place during the printing process. The easily interchange will keep the board on the conveyor. Even slightly board are kept in place reliably for optimum printing result. After clamping, the board is being retracted, allow a perfect print to the edge of the board. Okay, so meaning this sentence means that the PCB over here and this clamp is flat, is even. It's not like you have a off. Okay. Okay. Edge lock board clamp snap. Edge lock system secure hold the board during print using snugging technique. You all understand snugging? Snugging is like tekan. You tekan the board on the side. On the side. Pressing hard and pressing. This removes the need for top clamp which interfere with the PCB to the sensor contact, allowing full contact of the board to the bottom of the sensor. Then this is without optimal gasketing and more volumetrically consistent edge to edge print. Okay. So this will have a very good gasketing. Means that the PCB and the sensor will be fully contact without any gap. Right? This one later we will see at does that the machine gap. Later after the class I will bring you all have a look. Okay? So what is spring gap? What is spring gap? How it happened? Why the spring gap?
It's not really close to the sensor.
Okay, close to the sensor.
Yeah.
Voltage.
Yeah. How you all determine is a spring gap? How you see if I don't have any tools, I don't have any equipment to check.
I see uneven, so the place
If I just don't check about I newly set up the program, then how do I check? I don't see any printing yet. I didn't go through any printing. Just a backboard and the sensor. How I know there was a spring gap?
shadow.
It's so location.
Yes, you're right. Shadow. How you see you take your sensor, you load your sensor, and then your board is go up to the print height already, right? So you look, you open the light, open the cover, open the light, unless the cover is not there. Okay. So you can see that if there is shadow, or you try to mouse your sensor, see is it the sound is very tight, if the sound if there was a gap, it will like this, then the board possibly contact it will be like very thin and so on. Okay. Okay, so fringe gap. Check the fringe gap between the sensor and the PCB during setup are very important. Zero tolerance for gap. This cause poor gasketting and lead to undesired effect for the assembly line. And please do check the sequence below. You can take a photo of this. How do you check? Evenness of the PCB surface, correct use of tooling, voltage of the board, condition of PCB clamping on the transport rail. Condition of this one. Condition of the PCB clamping on the transport rail might be your snuggling is too hard. You set the snuggling force is too hard, causing the board is very warped. Or maybe your board is very thin. PCB is very thin. Okay, so when it's snug, it will warp. Okay. Then tension of stencil. Then condition of the top band. Dirty, inside got some surface, harder surface. Then transport band condition. Then damage affected on any location, loss tension. So, Mr. Paul, any issue? That's all you like this?
No, I just thinking the previous one why you want to climb from the edge. Because of the flatness.
I think yang printer ni tak ada struggle apa kan. Dia just
The front and bottom is like that.
Did you have a struggle?
I think we don't use that feature because we use our carrier, so
Oh, okay.
but for this, if let's say we don't use any carrier, then this is important. That's why NPM try to design the clicking to be as thin as possible, right? As you mentioned, like mine, right?
Right.
So that you can reduce the gap. I just keep repeating that.
It's okay. You can share. Okay. Okay. So what is a pinch stroke? Early in the morning, you all don't understand the pinch stroke. Okay. Pinch stroke is this is the distance for the squeegee travel across the sensor and we recommend to be minimum of 20 mm past the further pedal. The further stroke is important to allow enough room for the face to roll on during second or return stroke to avoid missing of solder paste during initial printing.
Sebab nak our method tu lah. No, our method is correct. We try to create more volume on the solder to have
This
a
is-
better printing. Yeah.
Oh, this very
Yeah. This one means kalau dekat ni, then the volume solder paste tak volume tu.
the beginning or the end one will become problem because the solder is not rolled even enough. Maybe some air trap inside bubble, it will due the particular temperature is not filling up. Right?
Yes.
So this is printing stroke. Printing stroke is mean forward and reverse stroke. You know. Do you understand? Can answer no? I cannot read the one because everyone is wearing the mask. Okay. Just ask, okay? So normally for sensor, this is our distance of the printing. Okay. Impossible that we print like here or here. We must go further. Okay, the squeegee must go further. Okay. Because if you have here, the paste might roll stop at here. Okay. Paste D. Understand of this? No. Can you paste the no? Kaka is stir. Right. It's actually stir is like this one, but knee paste is on the sensor.
Knit.
Sapu.
Bukan knit macam you orang buat roti kan. Dan roll.
So minimize the temperature fluctuation, keep the machine covered close, locate the machine away from the source of heat. Okay. But everyone is open the cover. Why? Why all open the cover?
We monitor.
This is for you.
This one.
This is for you. But for production, why?
You can top up the solar phase.
Yes. Then for the second hand, for the output. Right. But for those is very expert, but for new guy, they follow the expert like this, will cause more problem. Okay. Some material are also sensitive to change in humidity. Water soluble paste for intense tend to absorb water if humidity is high, decreasing their viscosity and degrading their later performance in the reflow oven. Humid will cause water soluble. I don't know how to call the humidity. Okay, so another thing is the temperature will affect the paste viscosity. Okay, follow the solder paste back 22 to 24. And this is working condition, it's not in the fridge. Okay, in the fridge 22 and 24, I think your fridge is already broken. You have to change the fridge. Okay. Okay, humidity too low may be dry up paste. Too high may cause the water absorption, particularly in water soluble paste. Keep to mid-range 40 to 50%. Your machine, every machine has the humidity sensor. Can check in the monitor. You know, no idea. Never noticed about it.
Yeah.
Okay. Okay. So for you guys, what is solar paste? What is solar paste? Okay, so what is a solar paste? Solar paste is a combination of pre-alloy, sulfuric metal powder and flux medium used in the manufacturing of print circuit board to connect surface board component to pads on the board. Okay? Understand?
Something like glue.
But glue is water. This one is a solder. So inside got solder ball. Okay. It's also possible to solder through hole pins in the paste component by bringing solder paste in and over the hole. You know PTH? You all know the PTH? Through hole component, like the connector. You also can bring. You also can bring. Then sometimes you will cover the hole also. Okay. The sticky paste temporarily hold the component in place. The board is then heated, melting the paste and forming the mechanical bond as well as the electrical connection. The sticky paste. What caused the paste become sticky? Sorry? The flux. Oh, because the shoulder wall is not magnetic, that's a spirit metal, so it's the flux. Yeah. Okay. Flux. Anyone know play the during soldering? We all play before during college. During before we solder, we will go and put something like butter, very fun, and the vapor come out, right? Okay, that is called flux, right? Okay, flux play a very important part in the soldering. It ensures successful solder joint is formed between the component and pads. Okay, flux has insufficient tackiness to hold the component while the assembly flux. Tackiness. What is tackiness? Sticky. Sticky. place your component already, your component are your pad, your flux your surface, and then your component. The component will hold on top of the component of the PCB. It won't like goes around. Okay, so this is called fuzziness. Okay, most of the solder paste come with flux. Okay, flux able to clean the surface of the PCB pad and remove the oxidize from the solder powder. It leaves a safe residue and protect the surface after soldering performed. Okay, so this is the solder paste type IPC powder specification, solder ball size. You can take a photo of this one. Everyone good? Okay, so for your information, type of solder base is not means that the larger the type of solder doesn't mean your ball is larger. The larger the solder ball, the smaller the larger number of the types, the smaller the solder ball. It's the opposite. Okay, so we have type 1, type 2 until type 8. So type until type 8. Okay, I heard someone is doing type 9 already. I'm not really sure. Okay, so normally our production we will use the type 3, 4, 5, 6, 7. So okay, do you want to help understand about this table? Understand? You understand? This is table for telling you that the type 2 the type 2 not larger than 80 micrometer, and then less than 1% are larger than 75, and then most of the solder ball are 75 to 45 micron. Okay, then 10%, no more than 10% are smaller than 20. Because our shoulder is inside our long ball. So what we are looking at? Normally which part we are looking at? 80%, yes, we are looking at 80%. Okay, we are looking at 80%. And then we are looking at the biggest number. We don't add on and then you divide by 2 and then get this 22 65, 60 something. No. We are looking at this one, 35, 35, 38. Okay?
So you really don't understand about that.
Next one.
Number 6, 50 micron up to 5 micron. What does that mean?
Around 15 micron to 5 micron. Because the micron 5 micron is very small already.
So it can go down to 5 micron.
No, you use the demos. Then you're printing.
Yeah,
Huh? I know. But for the USB,
USB,
all you see is the type 4. Okay? Okay, for your some of the, I can share some experience for you now. I go through the customer side, then the customer give me a survey without any discussion. And then, the thing they mention what type. They say no type 5. Can be used. Right? So this is what's the formula. And then okay, so this one is standard for the IPC. As long as you got an IPC means that is follow the standard. Okay? So this is an example of the showing the particle size of the shapes of alloy, type 3, type 4, type 5. You can for the picture you can notice that the photo is here is the actual photo of the solder from the microscope, and then this is we use the computer to zoom in. Okay, so from here you can see the powder is quite big, getting smaller and smaller, right? So the smaller is better. The price also very good. Okay. Okay, so order size are classified by according to the IPC standard, which is standard A0058. Okay, so the case storage. You all got handling the solar case storage before. Need to store the case at where. Alright.
And then one question, jadi sepatutnya less than 10 second and 10 degree ya?
This one is up to your spec. Up to your spec. This is my like referring. If you have to ask your, because they have some a lot of brand of the case and then depend on the parts you're using. Okay.
Because last time we did accidentally put in the negative 40 ya. Negative 40 screen.
Yeah.
Then we don't know what
Nothing there.
Nanti apa?
The color doesn't.
No, you won't have, because you already sealed that. Your solar base, your solar jar is already sealed. Sealed it, then you have to do going. You just need a longer length going because negative 40.
The flux also won't affect.
Frozen already. So it is critical that solar paste be received in and stored as soon as it arrives to the destination. Okay? Solar paste should not remain on the receiving dock where it could be exposed to excessive heat, humidity or cold. Okay. Then it generally recommend to store the solar paste in the refrigerator less than 10. Okay. Okay, so solar paste storage, solar paste inventory on the FIFO, first in first out. FIFO, understand? FIFO, first in first out means that you put the first one at the front, 放在后面，这样子给出来，拿出来先进先出，first in first out. Okay, store it in your refrigerator less than 10, then minimize the temperature fluctuation during storage. Storing at the room temperature is okay for a short period and may cause fewer problems than failing to normalize material taken from the refrigerator. So normally we will see you will see some description over here on the solar jar. It has the manufacturing date and then the store temperature and then used by. Okay.
Ini dia expired date. This one.
Okay. So this is normally the production date, expiry date 9. The solar base should not be exposed to temperature above 39 degrees Celsius, 84 Fahrenheit, which will be shortened its shelf life. Label the material clearly the date and time taken for the storage. So normally production they will put a sticker because they don't write on here. Production will provide a sticker in and out. Expiry date. Okay, so for this photo you can see this one is already the solar paste is already expired. If the solar paste is exposed to excessive heat for a prolonged period for time, however, the separation of the flux medium from the body of the paste may increase dramatically. Means that you can see here the thick one is the solar and then orange color like something like orange is the flux. Okay.
This one consider expired if condition ready. Yes.
The still use.
No, last time because my I told you I stopped in negative 40 minutes.
Uh-huh.
Then I out.
No, if your stay remain how it won't negative 40 it won't change to be like this. This is because you kena. No. This one is already kena heat. Apa? If you
become yellow, right?
orange, yellow,
orange.
like a layer of oil. You will find into a cloud. Okay? If the paste has received a heat damage, the thick deposit of the cloud will be floating on top of the paste. Okay? This is why we need to label in ready time, expired time. Otherwise, I put there, you open, you don't know, already expired, you just stir it and then you start to run. Wow, fantastic.
So this one expired after you open it, after you store how long? So it's 24 hours.
Depends.
Depends lah.
Depends.
Depends.
How long you will stay for in the room temp.
Okay. So, I'm answering your question. Preparing the solder paste, warming or thawing. Okay. Before soldering paste is used, it should be removed from the refrigerator and allowed to warm naturally to ambient temperature. Okay. Do not remove any seal, open or attempt to mix solder paste until it has warmed completely to room temperature. Okay. So typically warming and stabilization time for the solder paste is 4 to 6 or defined by supplier data sheet.
Okay, let's say if the one the lifetime for the room temp is 24 hours, then I open only use for 12 hours. Is it still eligible for 12 hours?
You can store it for
Store it back.
store it back, but you have to use it as fast as possible. This is for your economy sake. Okay.
It's not recommended.
Not half. I cannot say totally not recommended. You can store it for next day use, but don't store and then next month you open and use for the one is not necessary to require idea.
Means that within 1 or 2 days you use it back.
But for sure for big company, just throw it.
It's true.
Just throw it. Yeah. Because you are if in the automotive company you have to throw away it, cannot use. Okay. Do not force warm solder paste and as this may cause the flux separation or rheology problem. Okay. Rheological means that the characteristic of fluid flow. 明白。你的 flow 就是讲说你的浓稠度会变。它应该是这样的，可是它可能变成更加水。Okay. Okay, so handling, preparing the solder paste, stirring and mixing. This is stirring, just one is mini paste, okay. So once it has warmed adequately, mix the solder paste rightly and truly in one direction for 1 or 3 minutes by means of the spatula. You have to stir one direction. You are not kacau the Milo ice and this and this. You are kacau the paste, so you have to stir in one direction. If you another direction, you will cause air trap.
Movement, maybe 20 times like this, and then another 20 times like this, and then so still okay.
Okay, so second option is mix the solder paste using the mixture machine. You can buy a machine, SFP yourself, mixture machine. You just put the paste, then you stir for you. You spin.
Actually, we use mixer.
We use
but we
mixer.
still do it manually.
It's double work.
I don't feel safer to mix anymore.
And so
Okay. So this will ensure the evenly distribution of the solder paste. So the solder paste, after you stir with the mixer, you open like this. You become very even. Okay. This one will happen during if you top up half jar, then after that you run and then you top up again. Okay.
So the mixer ni nanti perlu how many angle ni kan? Only 2 angle yang pusing like this and another one is like this.
No, one direction.
One direction.
One direction. Your mixer will stop and mix.
Last time they need apa? At least 3 angle of rotation for mixing. One like this, and then another one the whole things will be.
So far, and the one I mean one is only one direction. One single direction.
Mixing direction that we have only 2 angle.
Oh, really?
I heard one
cartridge, jar and cartridge. You all saw the cartridge before. Jar. Jar is the one you are using, right? But cartridge is this one.
Oh.
Big one. This one you cannot stir already.
So just
Press.
just press.
Don't need to press. This one you still can stir. So once the jar or cartridge has been opened, it should not be refrigerated. Okay? You all just forget about just now what I say. You can keep it. You can temporarily forget about it first. That's why you say you come and then you put it back and then okay. So temporary forget first. So simply reseal the jar or cartridge and leave it out at the room temperature until it's ready to use again. Refrigerator place can cause any moisture that has been absorbed into the paste to condense, which can then result in moisture related problem. Okay, especially moisture for the water soluble paste. Okay. So applying the soda paste to the sensor. The initial application of the soda paste onto the sensor typically is 2 to 3 times greater than the application made during the print cycle. Okay. The soda paste should be full length of the printable aperture of the sensor and groove thickness limited approximately 15 mm. When the printer is running, moving, you can see the soda paste is on the sensor squeegee there, right? So it's approximately 50 mm. How to measure up? I can give you some suggestion is look at your thumb, the size of the thumb. Okay, those smaller than your thumb, bigger a little bit is okay, but not too much. Okay, but everyone's thumb is different. Okay, impossible your thumb is like this one, right? So it's like your thumb size. Okay.
We can use the squeegee or half squeegee.
Some of the users they will have a calibration tip, 50 mm. They will put on top of the squeegee paste, the paste, and then approximately if the number then they will pass. If fail means that the paste is passed. Okay.
That's a minimum one. We don't count on maximum.
No. Approximately 50 mm. Don't too much. Okay. It is better to add a smaller amount of paste more frequently than add a large amount of paste less often. This happens everywhere. Operator will direct down one jar and then go to check. Come back again, down one jar again, check again. Okay? This method of control ensure the more frequent turnover of paste keep it fresh. Okay. Very important the paste must be fresh. Okay. So I will answer just now what you are asking. So fried paste will take around 2 to 8 covering knife or wheel. Then put the printer. Okay. If you not enough, you didn't use finish, and then maybe you can put in the fridge. And then you use that tomorrow. Okay? But not for automotive medical product. Okay, that one direct through already, that one you will cost.
How about the soluble? Still can use like different.
If the condition is, if your paste is very good in good condition, then okay. But not highly recommended lah. Okay, so reuse soda paste. Only reuse the soda paste if there has been no printing problem. Okay. Then discard or remove use of or dry soda paste around the edge on the squeegee blade. Those
At the edge one we need to show.
yes, why?
Why? At the edge one, so then when I
Where?
squeezing, What? Need to throw out. What?
Because it's dry.
Yes.
Oh, this is after the.
No, while printing.
Oh,
Main.
during the.
After the during the printing it won't be happen if you the machine is already stopped for maybe 2 or 3 hours.
Okay.
Okay. So if you stick over here, don't save cost, go and correct all the things stop, then put it back. Okay. Okay. Store the good solder paste in sealed container not more than 8 hours. Okay. Do not mix used and used solder paste in the same container. The container you have must be labeled, no, used or new. Don't mix together. Okay. The exact procedure for reuse of solder paste will depend on its type and quantity as well as economical consideration. Don't type 3 and type 5 mix together. I have the type 8. Okay, you won't happen, right? I think we have a short break for 1 minute. Okay. This means that after you depaste the first time is what you learn, and then you have to clean it. This is an option. You use the depaste option. You start, you turn on, and then you will clean. Maybe this one is wet vacuum dry. It's another. Okay.
You stand still cleaning every time print you will do. Oh, so if you will do
You can set.
You can set every time whether
Yes.
or what.
Yes, you can set every few board. But definitely every board the second time will be impact.
Yeah.
Okay.
So if let's say a really good aperture design, you don't need to do any cleaning. I mean right after this print we can print another board.
Yeah. But in the condition of keep running, it's not like run, stop 5 minutes, then run, no. It's keep on running every 10 seconds or 30 seconds after you one more finish and then continue another one.
Oh.
This is a good condition, continue running.
Oh, okay.
Okay. Okay, so this is the sensor condition. The good sensor will have a high and predictable yield, will minimize the need to clean, enhance, increase throughput, and reduce both downtime and consumable use. A damage of one sensor may dramatically reduce yield and demand constant cleaning and inspection, adding considerable cost to the manufacturing process. A fault sensor, once identified, should be replaced immediately as the cost of replacement is manageable in relation to loss of production. Understand? You know, because of the sensor tested for a place and then you bend it back, then start to run. You can imagine that 1 hour you create how many bots? 1 day, 1 month, and then you will be all in the shift time. Okay? Okay, so sensor and squeegee condition. We have SME will sell the sensor cleaning machine. Okay, so it's if you don't have the option to have this machine, you can use manually, but you have to clean more. How you clean the sensor first? I need to understand.
Dry.
Okay, after that. Okay, you're missing one step. Vacuum. It's not it's not yeah, you can blow it. If the sensor is going to keep in the shell, keep in the storage, you have to clean it.
Just blow it.
Yes, you have to blow it. You have to blow it, okay? Then how you clean the sensor?
We pour the
FBA,
and then top and bottom.
Okay, you have
Our hand is a machine.
So during you clean the sensor manually, if you don't have the choice, or you have to clean both simultaneously. Don't like this, and then enter like this. You will push the solder paste up and down, up and down, up and down, up and down. Okay? Both together. So the solder paste you can press, you can push upward and push down together. You don't clean like this, and then the solder paste will come out.
Today.
Dry.
And then go. Before you store up, if you don't have the option of this machine. Okay? So dirty and temperature are one of the main causes of the process defect. So the sensor should be cleaned through clean in and automatically washing machine. Be able to store to storage and possible even at the shift change. Okay? The underspring cleaner in the machine is for production normal cleaning cycle only, and it not able to clean top surface. Okay, underspring cleaner is our machine. We call Viper cleaning. Our printer cleaning is only for the bottom side, because top side is what we going to deposit the paste to the PCB. Okay. For manual cleaning, use leaf-free cloth, soap, solvent soap cloth in both hands. Clean top and both sides simultaneously of the sensor. Okay. So this is the squeegee condition. Squeegee need to be carefully stored and maintained, as any damage can lead to poor printing result. Okay. All squeegee blades should be inspected before installation and replaced if they contain any edge flaws such as damage or dented. Operations should flag or stop printing when the squeegee is not printing properly. From the photo example of the squeegee or printer setup problem. Printing, but only half side is clean, other side is remaining here. Means that the squeegee blade already slanted or dented. Okay, this also. Maybe the center of the squeegee blade is already bent. Clear? Okay. The side of the squeegee should produce a smooth, shiny stencil surface with no bubble or streak of solder paste left behind. Okay. I would like to show you all some interesting photo. Okay, so do you know for the squeegee blade? Do you know how it look like in the microscope? You think how it look like? Because it's sharp. No, it's sharp. The shape supposed to be like this, or to be like it's flat. Sharp. Should be how the squeegee blade look like. Should be like the knife. The end, the edge is like a knife, or like this one.
This one,
Okay, show you photo. Okay. So the answer is like this. Okay. So if you want to check the squeegee is in the position okay or not okay. Maybe you cannot see it from the guy from the microscope. You have to see the whole line. Measure the whole line. Okay, measure. You just check the whole line. Is it here any dented or not? If dented, just throw it. Okay. Let's say this is the band end. Yeah. So So first line of defense for production side. So the first thing is the printing process and why we need to focus on the wiping function. The frequency of wiping option, wiper profile, event of environment wiping, advanced option, material paper, material solvent, preventive maintenance and random swap. Okay. You have to check the whole thing before you correct. Is it we done our duty first? For the printer is they found our default the defect from our side. Okay, so we have to check the whole thing. Is it everything okay? Then we need to check another where is the problem. Okay. So why the SMT sensor? Under sensor is definitely as important as the part of screen printing process. Fraction force for aperture more large enough to make much of the solder paste remain in the aperture. Printing process is a major causes of yield loss 50 to 75%. Okay. So here is explaining why cleaning process is so important. So when you print, the paste flow into the aperture and set up and stick both the sensor more on the back. Okay. Then the separation will pull the solder, and then after that it definitely will remain some. Okay. Then or some the paste also stick on the bottom side of the sensor. Okay. This is causing the particular pad got bigger. Full gasketing. Okay. That gasketing between the solder pad and sensor too high printer pressure. Press too high, the sensor will pop off. Still remember the squeegee formula for the squeegee? Then something bigger. Something. I like. Okay. So because for the normally for the new newbie, they will know what is that. So you just tell them this side divide by 15 plus minus. Normally it's plus 2 to 4 kilo. If possible, this one I see the metal must be very hard. I put 20 kilo. Then the time your stencil will press very hard, run, and then you can see your stencil is popping out. Okay. Okay. So contribute of gasketing issue. This one also you have to this is part of the defect already. So contributing of the gasketing we call the printing issue. Okay. So incorrect or variant board thickness, you key in the incorrect board thickness for the machine for the program. Poor design of the mask of the pad. Passport is called S totally level. The PCB is typically dripped into the bulk of motor shoulder that all exposed copper surface are covered by solder. I think you all see before the copper pad something is already soldered. Some process has. Okay. Then the barcode level is causing the poor gasketing because pop out, and then your sensor will follow up. Okay. Then loss of sensor tension, bottleneck interface for pallet, squeegee overpressure, machine contamination, variation of mass thickness, pad recess below mass. What is mass? This is mass. Green color is a mass. So the mass. Then pad supposedly is a little bit higher. You can feel it up a little bit higher than your mass. But if a poor design or poor manufacturing of the PCB, they will come with the mass layer is taller than the back. So when you touch, you will tap go down. You can feel it. Okay, so I proceed. So board blockage, then damage of one sensor, insufficient cooling support, vacuum. Vacuum will cause the whole gas vacuum.
Vacuum during the bulk suction for
You suck very hard.
Then okay.
It will come to board become blockage. Because the board, why you are using vacuum?
To hold this.
Why? To hold the PCB is correct, but why we use the vacuum? Because of the PCB or the substrate is very thin. Impossible you take the 5 kilo board and run with the vacuum, right? No, right? So the why we are using vacuum is because of the thin board. Okay. Then mismatch of the aperture to the wall. This one always happen. Okay. So how to determine the cleaning process for the newcomer? Okay. So inspect the sensor and ensure the sensor is clean. You print one board, you inspect one board. You print one board, you print two board, inspect. You take out the sensor and see the underneath. Is it? Okay. You print until you see it squeeze out, then you start to clean before 2 cycle or 1 cycle. Maybe you print 10 cycle and then the number 10 is already saw the squeeze out already. Maybe the number 8 can start the cleaning process. Don't exactly the 10. So this is what we want, clean and clear, dead, smooth, shining. Okay. So you can take the photo, but the photo regarding the white frequency is just a reference. Don't use this lemma. Also. Okay. Yeah. Because every board is different. Okay. You just say you talk to my boss. You see, white frequency 15. No, cannot 15. Then I differentiate you. Okay. So white type driver most common use. Okay. That's what we call wet vacuum drive. Okay, so maybe I start from the bottom side. So solder wipe used to address the flux on the bottom of the sensor. So you clean it and then wet it is called wet vacuum. Address the aperture to remove the paste address blocking of the aperture to suck out all the residue on the aperture. Okay. Then dry, most common use address the solder ball on the bottom of the sensor and cause smearing of the aperture. Okay. For your information, some of the process vacuum is not usable because maybe the water soluble paste is not like yours, right? It's very liquid form. You cannot use. You will drag all the solder from the aperture. The solder ball remains down, right? When you vacuum time, it will suck off, and then you drag all the solder, the what underneath of the sensor.
Yeah, using the soluble type flux.
Very liquid one. And then another thing is the next process will be improper because your aperture is fully dry. It's not lubricant already, so the solder is very hard to go through. Okay? You cannot totally clean, you have to lubricate some. Okay, so this one is just for your reference. Okay, you have to try. Okay, I cannot guarantee 100%, but we have to try. Okay, normally is we will start from 5, clean, then clean. I got one customer running 24 woman, they go to 60 now, but only one customer, the rest is around 5 to 10 minutes time to clean it. Common one is 5 to 10 to 15, but that one is 60, but provided no stop. Okay?
Working to time, working to
Very fast. That one depend. Okay. Yes. Okay, correct. I need to correct one. Solvent vacuum drive is called wet vacuum drive. Solvent is wet one. Wet vacuum drive is the most effective. The first vacuum might pull the solder from the aperture and form the static hanging from the aperture. Continue and index. This is what I want to teach and explain to you what is continuous and index mode in your NPM machine. Next time when I go installation, I ask you all don't know how to practical. Okay. Okay, just joking now, okay. So the continuous mode, what is the continuous mode? Advanced. Continuous mode means that advance the paper during vital motion, ensuring fresh paper is applied during the wide maximum paper consumption. Okay. In that mode, paper is run predetermined amount then stationary during vital motion continuous paper consumption. What is the difference between these two? You understand? You understand? You understand? Doing right? Understand? Okay. Continuous means that during cleaning cycle running, the paper is running. The paper is running. Then the index means that the paper will run for certain of length and stop it. Okay. This is for sure the continuous mode is better because the paper is still running very clean. But some they will think the paper roll is very expensive, so they will index. This depends on your boss. Okay. Then this is what people always will no experience will miss out. After the printing cycle, after the cleaning cycle, you will see a lot of line.
On the bottom.
Bottom. On my machine, my cleaning is on the bottom, possible on top. Okay. The cleaning unit you clean like this, then it's on the line. Why? Because
Continuous index.
some is yes. Because of the index.
Yeah, you use the
Because
same paper to
set paper, then the paper is already drawing. And then the remaining one is cannot absorb at the paper already. It start to pulling. It pull the residue. Okay? Very important. Don't ask me how it why got mine. I also don't know. No, just let you know this one, okay? Oh, hop over. Hop over to adjust the smearing effect. Retract random and move over the end point. Okay. This is all what you will find in the NPM machine. Okay. Over travel, the white stroke predetermined by the squeegee stroke, a large extension of the stroke, eliminating of the whole finger is present. This is what I mentioned just now. Over travel. Okay. Wiper speed. Recommended speed of wiper or solver stroke 2 inch per second or vacuum stroke 1 inch per second. Vacuum, the slower the better. But also determined by your second time. Okay. I know everything slow is better. But output cannot come out is problem. Okay. Okay. Event driven the wiping. Key event that can trigger defect. Pause in printing. Okay, first 4 printing during initial setup. Is it? During setup parameter, the first 4 to 5 will have a lot of problem, and then the continuously will also have problem already. Is it? Yeah. Okay, additional case. Why always will happen first import will have this issue? Because the aperture, the wall aperture is not fully lubricated. Some paste is like this. Okay. Then custom what to target specific event in the printer. Cost of printing, the paste based on the paste behavior, recommended medium plus white. Need function. Squeeze out is the issue. Heavy on the driver, no solvent. Okay. During paste dispenser, utilize window do additional but paste dispense, some machine they have the auto paste dispenser. Means that you buy the cartridge, you plug in, and then you don't do anything. Machine will auto count. Every 25 cycle or 30 cycle they will auto prime the paste. Yes. But I'm not sure your machine got or not. No, I'm not sure about that. Okay. That is another thing that need to focus. Micropaper. Okay. Need to focus later on. Okay. Printer are as good as the material that you put into it. The same can be applied to the wiper. During using the local paper directly influence the wiper ability to clean the stencil. In general, there are two types of paper used in stencil wiping. Paper made in synthetic fabric, help during the glue or the binding, and the paper made from mix of natural and synthetic fiber that do not use glue. Okay, the paper ability to absorb both the solder and solvent reflect on the cleanness of the stencil. This is very important. The paper ability to absorb both the solder and solvent. Okay, this is for your information only because this is not every country, every place they are different. But okay, blue glider. This one I can say for you because it's different. Okay, synthetic fabric found in paper usually are polystyrene or red. Okay, hydrotangling single fiber polymer. Okay, this is what the important thing for the wiper paper, because the solvent I cannot capture the photo. Solvent is transparent, colorless. Okay, so you drop one drop, single drop of the IPA, and then you see your paper. If you got few supplier of the paper, you can see the absorption, which is the best, which is not best. Because the better you put one drop and then you can spray out acting very good, means that it can absorb the solder and then the solder can be absorbed. Otherwise, the paper cannot absorb a little bit, and then the IPA will go up from the side, and then the whole wiper will be floating off the IPA. Okay, this happened before. Most of the customers, you can feel the texture of the wiper paper is something like paper. Our newspaper is very thin, right? So it can absorb, but it cannot absorb like the lint-free paper. Okay. Possibility is for those small company. They want to cut costs, but this is causing the whole wiper to floating off the IPA. And then how you determine the wiper is good or bad? You install the wiper paper, and then you run the solvent, the IPA on the wiper, and then you can see the whole line come out immediately. This is the good. And then you don't back until overwetting. Okay. Okay, so we are using the IPA. Yes, everyone know the IPA isopropyl alcohol. So it's for IPA. Then the chemical compatibility with the soda paste, dissolve the plug and bring up the soda powder. Whereas not bad reaction with paste that affect paste viscosity. Okay. What kind of they have some brand of the IPA, but some IPA have not good as good one. How to define the good IPA? after cleaning your hand, you will saw no white powder. The one is a good. Then is the good one is a cheap one. You will saw a lot of white powder. After you put IPA, and then the more you breathe, right, you will find that your nose is like very dry. Then there was some few powder inside your nose. Yes, and then you will make this one very white powder. Okay. So a good one is good, left no residue. So after cleaning of your sensor and motor side surface must be shiny and smooth after wiper cycle is performed. Possible you have still dirty, right? The aperture will completely clean and clear. So you can we can see that from the microscopic show that the wiper paper entraps the shoulder ball. That's why I said just like if you use paper, the texture is flat. You won't capture any shoulder ball. It's just like pass through only. Okay. So this is what is underperformed. The cleaning cycle, the wiper paper, the cleaning unit in the machine is underperformed. It's not good enough. Okay. Okay. In the machine, I can explain the process. Okay. In the machine, the wiper, you all see the wiper before. Okay. Now, the wiper in the machine, before it starts cleaning, it will push toward to the sensor. It will push very hard, not very hard, it will push forward, and then you saw the sensor is like in front, it will saw some out, go through. Okay, if you didn't saw this come out from the sensor like bengkak, okay, means that the wiper paper might be need to maintenance because it cannot fully touching the sensor, and then when it wipe, it's like just touching it, no very suction force on the sensor. Understand?
I'm just asking, is it really effective? Because when you want to put something, there's a hole, so for example, there's some solar case. Normally, when we want to do, possible you will push it back to the upward direction for the remaining solar.
That means your solar case for problem, your aperture for problem, or your incorrect using incorrect solar case. Because supposedly the aperture must be very clean and clear after you clean.
Even on the sub wall of
So the cleaning actually is targeting
underneath of the
So example underneath of the sensor we have. So when I push,
is it possible to
you ask people it will sit on the paper.
After you print, the surface of the sensor must be top surface must be very shiny. Means that you don't have any solar case.
So now we cleaning from the back,
same both side. You can set both side. Vacuum, very. I understand that you mean that if the remaining in the aperture, it will push up a lot. In the normally it will suck already because back you just wipe vacuum and suck all the and then dry and wipe.
So wet is not really pushing it's just
push, but it push, but it's not pushing too hard until your solder come out. It's like I just lap only.
So my condition is happen let's say I don't use the wet vacuum, but those use the dry, then it will possible will happen this kind of.
But if you don't use the IPA, then it will not very clean. Then your condition, I know, if just in case if the IPA you touch too much until the paper is too bad, and then it will definitely come out. Okay. Okay. So the PCB board consideration. Okay. So the PCB board design can be impinged on the effectiveness and quality of the print process. we need to see something important. Uneven pad surface can cause loss of gasket, searing result, and bridging, etc. Okay. If the resist is higher, that the pad, the gasket seal will be lost, resulting in bridging. Means that the mass is higher than the pad is lower. Okay. Underside component can restrict the use of tooling pin, crypto, wiglock, vacuum and special design of lock. Okay. Large underside component may impede board transport, increase under clearance. So when you PCB design, you have to consider few things. For the printer side, you have to check the tooling, is it correct, and then the support block, then the transport, is it correct, and then every machine have the limitation for the underside of the board. Not every machine can go to until 50, 40, maybe 30 already. You print in the source image, but below already for the component. Maybe some machine is not even capable for that. So you have to make sure first. Okay, otherwise it will crash. Okay. You all understand, you all know about via holder. Okay. For the old guy know, for the new guy, via holder know. Okay. Here I don't have the via hole. The via hole is just a hole. It's a hole for the connection. For connecting multi-layer, right? Internal, they are connecting like maybe the layer 2, layer 3, layer 4. Because for the PCB we have multi-layer. It's not only for one layer. We look one layer, but internally a lot of layer. Okay? 它们是很多层，然后它们是接些的。OK， 那个是标。OK。Therefore can cause problems with vacuum tooling. All the vacuum become no vacuum because out. Okay. Label, barcode, sticker, etc. increase the board thickness due to the tooling, printing pressure problem. Okay. Board warping. This one you can take photo. A lot of people don't know. After the second refill, it will pop. Color change, full surface finishing, edition quality, chamfer edge. Okay. And then, yeah. How big is the board you all running? So far you all encountered. Almost this size. Bigger than this size. This one is size. The warping is not very obvious, but the board it goes to 400. You can see the warpage. Then some of the board you can spin on the table one. Once you flat table you can spin because of the board. Okay. Now is you want to have a 5 minutes break? I need to stand by your phone. This is a very important for you all.
Yeah. Okay.
Okay, good. Okay, this is print defect. Okay. Okay, so phase misalignment. So the potential cause, the financial accessible is too low. Okay, programmable offset issue. Okay, sensor design incorrect. PCB spring or stretch or walk after refill process. Early in the morning, you ask me scooping. This is the design. This is the photo of the scooping. The pressure too high, speed too low, board voltage, poor tooling support, tensile pressure too large. Especially for those printing the high power component like the connector, the transformer. Okay. Okay. incorrect paste deposit or insufficient. You all see from the SPM machine, you all know the effect. Roughly know the name. Agak can know lah. Okay. So this is because for production side sometimes they don't know the name. You have to educate them. This is what. If they give you the wrong name, then you will go to and mislead you to another place. Okay. So here is the potential root cause means that when you encounter this incomplete place, you have to see, is it the pressure too low? Is it the speed too high? Okay, saturation speed is too high. Programmable clean cycling issue. Okay. Insufficient for support. Stencil tension is not good. Insufficient pin deposit. Stencil back after cleaning. What is that? Stencil back after cleaning. Causing the solder paste become the solder dissolve. Okay. Paste is too cold or poor mixing. This usually happen during the operator or technician they don't know about the meaning of flowing. Take off the fish, take on the fish, go in, do some I just go. So you have to educate them, let them know that the solder paste have to flow in to certain temperature. It's not like I take out and then I stir and then go. Okay? Then paste missing, clogging. Okay? Programmable cleaning cycle issue, releasing not good, incorrect use of solder tab or incorrect sensor aspect ratio. Paste is too cold or flow mixing. Okay, contamination, solder ball. Smearing underneath of the sensor during the full cleaning cycle performed as I mentioned just now. The next one come in, the first one is clean, then the next one, there was some remaining residue on the sensor and then they bring it to plastic. It will cause this kind of contamination solder ball. Okay, and then this solder ball will happen on where? On the solder mask. You won't saw on the contact because solder mask it will become more. After that it will become more. Okay. Bridging. Huh? Yes, stick together. Okay. Bridging, it means that I stick to the side. Smearing on top. Smearing like peeling. Okay. Bridging, the pressure is too low, speed is too high. Programmable cleaning cycle issue, doppling gap, program offset issue. Solder paste become watery due to environmental condition outbreak. Too many solder paste, stencil tension too low. Then poor PCB gasket.
Pressure too low.
Okay, first thing first, I can tell you all, if today I'm running product A, I'm running, I didn't change anything, but suddenly today I have bridging loss. What thing I should change? What thing should I check? You don't go through to the pre-speed and pre-pressure because from the history I'm using this parameter for so long, so I should check the pulley or is it the stencil issue. If today I'm running the new product MPI, okay, first I run bridging it, then I start to change the pressure or change the speed. Okay, two conditions. Okay.
Why the pressure too low will cause bridging? Is it because of the gap? Dia tak dapat tak?
Tak dapat yang resmi tu besar. Right.
How to say the pace too low. For if you saw the bridging, you can saw one thing already because there was residue on top of the stencil. Because the pressure too low, it's suffer a lot. But if I pressure accurate, what they need up, it will direct cut away the solder transmission.
Also that means that this happens is like too low, so there's the remaining up,
too
then
much.
when I take off, then the is slightly higher than it drops.
Yes. Oh. Okay, SSC. Pressure too low, speed too high, potential will concern. Okay, insufficient port support, got print gap, too many print deposit, excessive pre-stroke, phase deposit become watery due to environmental condition of the region. Okay, squaring. Because squaring, because dog ear, excessive height. But excessive height is inside the SP dimension. Okay, separation speed is too high. Okay, then pressure too low, cause the surface of the stencil not clean after print, got print gap or print speed too high. Missing edge. Missing edge. Missing edge and incomplete. Missing edge is missing. Okay. The pressure is too low, speed too high, incorrect port support, evenness of the port to stencil. Clogging stencil aperture. So the paste too cold or not well mixed. Stencil red after cleaning. Insufficient of solder paste. But this one is directly can see the solder from the squeegee there is insufficient. It's not more than how many mm? How many mm we need for the solder on the squeegee?
Oh, on 15
Okay, okay, very good. Okay, incomplete pads fill horizontal. Incomplete pad fill horizontal pad only. Check for the damage squeegee. Insufficient solder paste. Okay. This the random solder ball away from the pad area. This is from after removal. After removal, refrigerated paste open before coming to room temperature. Directly up from the fridge before the use. Paste deposit built up underside of the stencil. Before preheat temperature too high or too long. Improper cleaning cycle, moisture trapped in the solder paste. This is what I want to mention. If you use the moisture right, it will cause this.
It's like during the reflow, it's like the water evaporate and then explode.
So this is very important, very crucial for the water soluble. Because moisture is trapped inside.
This one I thought it's a flask. I thought it's a cup or it's solder.
So that you can fill up.
This one cannot.
Cannot.
They after you cool down they cannot when after you come out from the reflow you still can fill it out.
Okay, so now you understand now again. Need cheap solder ball. Excessive paste deposit. Okay. So excessive space deposit means that here and here is the solder is too much already, and then when it melt, and then the component will, due to gravity, it will fall out, it will split out. Okay. Before preheat temperature too high or too long, excessive component placement pressure. You press too hard and then squeeze out. Then sensor aperture to pad ratio incorrect. Okay, erecting. Erecting. Okay, erecting happen at the thermal pad after reflow. Okay, first is the PCB contaminated, already oxidized. Okay, and then poor solubility of the pad. It cannot expand. It just become raw. And then before preheat time and temperature is too long. Okay. Bridging of SOIC. Okay, so excessive of solder deposition, stencil aperture to pad ratio incorrect. Maybe open too big, and then when solder you join together. Okay. you press too hard, and then you press too hard, the solder become, the lid of the solder become big, too near to side by side.
What is the difference between de-wetting and non-wetting?
Sorry?
Non-wetting.
De-wetting.
And non-wetting.
Not wetting.
Non-wetting.
De-wetting and wetting. Wetting only. Wetting means that the solder will become
De-wetting means that non-wetting,
Yeah, almost similar.
similar, yeah. This is wetting, good wetting, this is not good wetting. Although it's a copper pad, but it cannot fully cover with the solder base. Okay, console. Last but not least. Okay.
Yeah.
Okay, concern. What is concern? Contamination of the PCB or the component. Okay. Incorrect aperture of the sensor or PCB layout. Uneven wetting force at both ends of the component. Placement of set. The supposedly to put at the center, but is slightly left on the right, and then causing the drag force. Reflow oven heating rate too fast and heat distribute is uneven on the PCB board. Releasing not good, incorrect use of solder paste type, or incorrect sensor aspect ratio causing uneven height. That's all. Okay. Thank you. Any question?
Defect billboard not related to the solder.
Billboard is the console. It's something that console is very hard. Yeah.
Related to the solder.
Need to see the condition.
Billboard is more to placement. Yeah.
Because the placement is already usually happen at the resistor. Because the resistors during pickup is already billboard. Tombstone is already stand up as one side, and then billboard is the whole thing is still at the compact. Any question?